This is a lecture from OpenTuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
All right, I'm going to work through the chapter on measures of average and dispersion, and I'll explain exactly what we mean by average and dispersion when we come to it. There is quite a lot we need to get through in this chapter, and so I will break it into several shorter lectures. And before we get on to average and dispersion themselves, there are a couple of things I need to go through that sort of lead up to it. And the first relates to what we call frequency distributions. Not quite sure how I wrote all that down, since you've got it in front of you, hopefully, in the notes. But you have a table there. I think it's the same table I used in the previous chapter when we were looking at probabilities. But there's a table showing the number of complaints and how many times they happened, how many weeks they occurred, I beg your pardon, over the last year, the frequency. So over the last 52 weeks, 12 weeks there were no complaints, 16 there were one complaint, 20 were two, and 4 there were 3 complaints. And that's fine. The number of complaints is only going to be 0, 1, 2, or 3. And it can only be those 4 outcomes. And so I've listed each one and the frequency. And we say there the variables, which are the number of complaints, we've got discrete variables. I've listed every possible result. It will either be 0, 1, 2, or 3. And that's fine. Fairly simple little table. But if you look over the page at the next table, it says we recorded the total amount paid to employees each week. And you'll see the total. It turns out in our company, the total can be anything between 0 and 3,000 a week. You know, maybe the number of employees keeps changing. Well, to list every possible total will get a bit ridiculous, because surely the total I paid in the week could be 0, could be $1, $2, $3, $4, $2,000, $2,001, anything up to a total of 3,000. And to start listing every single total, it could be the total's different in every week. You know, so 52 different totals all occurring once isn't really much use to anybody, and perhaps I don't need that detail. And so for something like that, it perhaps makes more sense to do it in groups, as you can see. You know, we've said the total paid, naught but under 500. 500, but under 1,000. So if they're between 0 and 500, well, that happened once. And I don't really care whether the total was 200 or whether the total was 300. It was in the range 500 to 1,000 4 times. It was in the range 1,000 to 1,500, strictly under 1,500 8 times, and so on. I've split them into groups. All right, I haven't got as much precise detail, but I probably don't need it, and it's much more manageable. Well, when we've got that, we say we've got continuous variables. It just makes it more manageable, split into groups. So nothing much there, just terminology, but you'll see the relevance later when we come to look at averages and dispersion, how we deal with it, whether we've got discrete variables or whether we've got these continuous, we've got these groups. The next thing in this chapter, it says ways of presenting data. Again, you'll see, well, this is relevant on its own for the exam, but you'll see the relevance to these averages and dispersion shortly. But management aren't always accountants and understand numbers. And often it's better to present data to management in the form of some sort of chart or table, rather than just a list. You know, those frequencies we just looked at. Okay, that table's not hard to understand. 1 week, we paid between 0 and 500, 4 weeks we paid 500 and 1,000. But, as I say, management often find it more obvious, easier to deal with if we give them the information as some sort of chart or diagram rather than just, a set of numbers. And you should be aware of 4 different charts, diagrams that we may use. The first of which, something called a bar chart. Where, forgive me, I'm not going to waste time here with a ruler, so I won't be pretty, but with a bar chart for that information, the information in that table, what have we got? The various ranges, it was 0 to 500, 500 to 1,000, 1,000 to 1,500, 1,500 to 2,000, 2,000 to 2,500, 2,500 to 3,000. So there are the different groups, the different ranges. And against each one, we'll do a bar. The length, the size of the bar will depend on the frequency. So if along here we've got frequency, 0 up to the biggest frequency was 19, so if I got to 20, we then do a little bar for each. So 0 to 500, there was only one. It only happened once, so there's a little bar, sort of 1 unit across. 500 to 1,000 was 4, so there's 10, there's 5, there's 15. So we'll do a bar 4 units long. 1,000 to 1,500 is 8, which is what about there, so I think you can see what's happening. 1,500 to 2,000 is 19, which is up here. Whoop, boop, boop. 2,000 to 2,500 is 14. And finally, 2,500 to 3,000 is 6. So as I said, I'm not going to waste time being ever so pretty here, but I think you can see what's happening. So it's just a bar. That's why it's called a bar chart. But makes it obvious at a glance. Which was the most, what you might call popular range. We can compare. So that's all a bar chart is. A pie chart you'll see why it's called a pie chart in a moment. But this sort of chart, we do a circle and split the circle into chunks, slices, the size of which depends on the frequency. So here now we do need a little key. I'll use this colour to be 0 to 500. I'll use this colour to be 500 to 1,000. This colour 1,000 to 1,500. I wonder if I've got enough colours here. This colour 1,500 to 2,000. This colour 2,000 to 2,500. How many more? 1. Have I got another colour left? This is another shade of blue. 2,500 to 3,000. And I'll use those colours to divide into slices. And so 0 to 500, the frequency was 1. And it's 1 out of 52. And what percent is that? 1 out of 52 is, where's my calculator? It's just under 2%. And so what I do is I do a slice of this circle which is 2% of the total. We don't normally write in the percents, but that one, blank. Uh, 500 to 1,000 is 4, and 4 out of 52 is 7.6, nearly 8%. And so we'll do about a slice 4 times bigger. So this one's this colour, so... Oh, I haven't changed the colour. Boo, 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 boo. It's that one. Uh, 1,000 to 1,500, 8. So that's twice that one, twice the 4 one. So I'll do a chunk twice as big. That should be red now. Oh, sorry, I could have been a lot prettier, but I hope you see what I'm trying to do. 1,500 to 2,000 is 19. Well, out of 52, that is 36, 37%. So this is going to be quite a big one. Nearly there, may as well finish. 2,000 to 2,500, 14 out of 52. About 27%, which is, ooh, perhaps like this. Oh dear, it should be green, sorry. And fine, I'm sorry, these they've been coloured in properly, you know, not just a few squiggles. But finally, 2.5 to 3,000, there are 6 out of 52, which is the remaining 11 or 12% and would be this bit here. And of course it's a pie chart because, well, it looks like a pie cut into slices. One thing to bear in mind, you should know, I think, from school, that there's 360 degrees when you're going all the way around a circle, 360 degrees. And therefore, if we're doing, oh, let's say 2,000 to 2,500, there were 14 people in this group. There were 14 out of 52. And so the angle of that slice will be that proportion of 360 degrees, which is 284 degrees. That can't be right. 14 divided by 52 times 360. That's better. 97 degrees. Not percent, degrees. And so that's how you'd actually draw one, being precise. Now again, you're not going to be drawing full ones in the exam, but you can be tested that you know what a pie chart is. And you could be asked what these angles would be. It's whatever proportion of the total, which is 360 degrees. All right, well, I'm embarrassed by that because it's not very pretty, but... Next one. The next one, see a histogram. This will look a bit like a bar chart. It's very similar, but it's quite important for what's coming later in this chapter, in the next chapter. But with what a histogram is, for the same data, along the bottom we show the variables. So it was 0 to 500 to 1,000 to 1,500 to 2,000 to 2,500. And we do bars again, this time they're vertical instead of horizontal, and the height of the bars will depend on the frequency. So 5, 10, 15, 20. So I say it is going to be very like a bar chart, except, and you'll see how important this is later on, as I mentioned, but the bars will be next to each other. What I'm getting at is 0 to 500, the frequency is 1. 1. 500 to 1000, it's 4. 1000 to 1500, it's 8. 1500 to 2000 is 19. Oops. And finally 2000 to 2.5. No, I forgot to do 3000 anyway. 2000 to 2,500 is 14. And finally 2.5 to 3000 is 6. And so that is our histogram. Now, just one thing about this, which will be very important later, and I'll mention again later, is when we're doing it, it's actually the area of the bar that's proportional to the frequency. Now you should know that the area of any bar, it's the height times the width. The reason it's important is this. It isn't necessary in our distribution that all the ranges, the gaps, should be the same. For instance, we might have decided to have the first one as 0 to 1000, and there's a total of 5. And then have 1000 to 1500, total 4. 1000 to 500, where am I? 1000 to 1500, total 8, I beg your pardon. 1500 to 2000, total 19, and to carry on the same way. Well, all the later ones are the same, so boom, 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 boom. But this first range, 0 to 1000, it would be rather stupid to do this, to say, oh, there are 5, let's do a bar 5 units high. It distorts it, it makes it look a lot more popular than it actually is. You know, because 0 to 500, it's only one person, right down there. 500 to 1000 are 4 people. And yet, put it together and draw one bigger bar. It looks a bit silly. And we say no. Because we've now got a group that's twice as big. All these others are 500, this one's 1000. And so, because it's twice as big, we'll make the height half of what it would be. So instead of showing a bar 5 units high, we'll show a bar 2.5 units high. Now, we lost a bit of accuracy, obviously, by having that first range 1000 instead of 500, but replacing those 2 original bars with this red one wouldn't look anything like as distorted as it would do if I put one up there. Now think about that. For the moment, I'm not too worried. I'll show you later why that becomes important, and I'll mention this aspect of it again when we come to it. Finally, the last one you expect to be aware of is a rather specialised one, D, an ogive or ogive. And what this is, we show what we call the cumulative frequency. What I mean by that, if I write the original table down, 0 to 500, 500 to 1000, 1000 to 1500, 1500 to 2000, 2000 to 2.5, 2.5 to 3,000. Well, we know what the frequency is from the original table. 1 week, 0 to 500. 4 weeks, 8 weeks, 19, 14, 6. We then look at the cumulative or total frequency. And we say, how many weeks was it up to 500? 1. How many weeks was it up to 1,000? Anything less than 1,000? Well, 5. Of 5 of the weeks, it was anything between 0 and 1,000. How many weeks was it between 0 and 1,500? 5. 13. 13 weeks it was between 0 and 1,500. How many weeks between 0 and 2,000? Another 19, 32. How many weeks between 0 and 2,500? Another 14, 46. How many weeks between 0 and 3,000? Another 6. Well, there's the total of 52 weeks. So that's what I mean by the cumulative or the total frequency. And then we draw a chart showing the total or the cumulative frequency as against at the top of each range. So 0, 500, 1,000, 1,500, 2,000, 2.5, 3,000. Well, of course, there was no frequency of 0, but 1, 500. I'll do a scale. We need to go up to 52. So say 50, 10, 20, 30, 40. All right, up to 500 was 1. That's what's there. 1, 500. Up to 1,000 was a total of 5. 5,000 there. Up to 1,500, a total of 13. Up to 2,000, a total of 32. Up to 2,500, a total of 46. And finally up to 3,000, well, of course, that was all 52. And we join them up with straight lines. So it's a rather odd one, I know, guys. It's used in rather special cases. If it was individual salaries, this might be a lot more relevant to show, you know, the proportion of very highly paid people as opposed to low paid people. But regardless, they're the 4 you need to be aware of. ogive, histogram, bar chart and pie chart. Okay, I said I would break this lecture into several. So we haven't yet got on to averages and dispersion, but you'll see why this was needed as a lead-in. But be clear, the different ways of having a distribution, discrete and variable and continuous, and these different charts you expect to be aware of. I say I will pause this one here, but in the next lecture, we'll start going through the different measures, first of all, of an average.